So this is week 37 Friday, and number 3 says, how many 3-digit numbers with 3 different digits are divisible by 11? So we can start by just listing some possible numbers like 1, 3, 2, 1, 4, 3, dot, 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 and then 209. And then you can see that this is a bit tedious. So we can just organize it based off of the tens digit. So from 0, so we can do 0 to 9. And we can start with 0. So there are two cases. One where they sum to 11, or actually, one where they cancel out, one where they sum to 11. Because the divisibility rule of 11 is where if you have a 3-digit number and you have A, B, C, then A plus B, A plus C minus B is equal to a multiple of 11. And 0 counts. So in this case, the only possible numbers are 0 and 11 because you can't have 22 because that'd be too big. So we have two cases, whether one, the 3-digit numbers sum to, the formula sum to 0 or to 11. So if we have sum to 0 here, well, there are no choices because the only number that sums to 0 is 0, 0, 0. Why isn't my pen working? Please ignore my okay, here it is. So the only choice was 0, 0, 0, 0, which isn't a 3-digit number, so there are none. For 1, there's only 1, 1, 0, which also doesn't work. For 2, we get 1, 2, 1, which doesn't work because we need 3 different digits. And for 3, we can finally have 1 where it's 1, 3, 2, or 2, 3, 1, which make up 2. And for 4, we can have only 1, 4, 3, and 3, 4, 1. And we can't have 2, 4, 2 because they have to be different digits. And for 5, we can have 1, 5, 4, and then the other one, which is 4, 5. Like when I'm referring to the other one, I mean it when it's flipped over because it's, if one number is divisible by 11 and then you flip it over, for example, these two, they're always divisible by 11 as long as the number of digits is odd. So you can see that 154 and then 451, which is the other one. And the other case is 253. So in total we have 2 times 2, which is 4 cases. And same thing, we have 1, 6, 5, and 2, 6, 4. And then that makes for 4 choices again. Then for 7, we have 1, 7, 6, 2, 7, 5, 3, 7, 4, which make for 6. And for 8, we have 1, 8, 7, 2, 7, no, 2, 8, 6, and 3, 8, 5, which also has 6. And finally for 9, we have 1, 9, 8, 2, 9, 7, 3, 9, 6, and 4, 9, 5. And these make for 4 times 2, which is 8. So we have that many for if A plus C minus B sum to 11. Okay, we can just write that for reference here. A plus C minus B. And if they sum to 11, we can see that. So we can start from 9. And so if 9 sums to 11, that means it will sum to 20. So that's not possible because it's just not possible. Because a plus c, the maximum is 18, and because 9 plus 9, and even with that, there has to be difference. So not possible, not possible. Because this sums to 19. This is not possible either because this sums to 18, and 999 is not an optional choice. And so starting from, 979 is not optional. So starting from 6, we can have this sum to 17. And then we also do not have a choice in this. Oh, we do. So we have 9, 6, 8, or vice versa, which is 8, 6, 9. And so we have 2. And then I could just write 16, because 11 plus 5 is 16. 15, 14, 13, 12, 11. So number 5. So 5 has 16. And so then we have just 9, 5, 7. And 7, 5, 9, which makes up for 2. For 15, we have 9, 4, 6. And then 8, 4, 7, which is 4. Then for 3, we have 9, 4, 9, 3, 5. And then 8, 3, 6, which is 4. And for 13, we have 9, 3, 9, 2, 4, 8, 2, 5, 7, 2, 6, which is 6. And then for 1, we have 9, 9, 1, 3, 8, 1, 4, 7, 1, 5, which is 6. And then finally for 0, we have 9, 0, 2, 8, 0, 3, 7, 0, 4, and 6, 0, 5, which sum up to 8 because 4 times 2. So now we can sum these up and we can see that these two sums are exactly the same because the 2's match up, and 4's and the 6 and the 8. And then so we can just calculate one of these and then multiply it by 2. So adding this up, we get 32 times 2, and we get 64. So the answer is 64.